Hi everybody, this is Mrs. Ellsworth, and what we're going to be talking about is some ways for studying for our test. Let me show you a couple things I do know. First of all, let's talk about what matching looks like on this test. So let me get something going here. Okay, so like if I had matching for like something like this, where you would go and select things. So what oinks, a pig does. Okay, a lamb says ba. Okay, so you get the idea of what matching looks like in on a Google form, and so and you can see I picked one apiece. Okay, and so that's what it would look like on Google form for matching. I wouldn't ever want to create a matching that was so long that you had to move it up and down and up and down. I'd probably do more than one matching section because because right now we don't get any classroom instruction, so that doesn't work so well. Anyway, so I also want to talk about the different kinds of the different responses that you gave me, and that I saw that we had that people wanted to look at different formulas for some different simple machines, and that some people were worried about identifying different machines. Only half of you guys responded to this question, so we're going to do some of the things that were the most. This is 5 people, 4 people here, and 4 people there, and 3 and 3. So we'll go over some of these things here quickly, and then also I want to remind you that there is a Zoom session tomorrow, or today. I guess you'll be seeing this then. So that is at 1 o'clock today. Okay, so let's continue. So let's talk about just identifying the different types of simple machines here real quickly. And I just went and pulled up this one picture. And okay, and so a pulley, of course, is defined as having a grooved wheel with a chain or else a wheel around it. Okay, how is that different from a wheel and axle? A wheel and axle. A wheel and axle. None of these other ones have a grooved wheel with a chain or a rope going through it. Now, like this right here is a pulley. I don't know why I have this weird arrow here, but there's a pulley, and this pulley it's a grooved wheel, and it has a rope going through it to hold that flag up. Okay, well, other ones, incline plane, but these ones are ramps. Okay, here's another incline plane. It's a screw. This screw top on here is a screw. Okay, incline plane on this Edison bottom of this light bulb. Incline plane. Heck, even a ladder is an incline plane. Okay, these ones are ramps, all ramps. Okay, wheel and axle again. Here's a lever because we are pivoting on one point. We are pivoting. In fact, you pivot on this point right here of the wheel too, on the wheel and on the wheelbarrow. Your scissors, you pivot right here also. And this right here is showing like a teeter-totter. So that's again another one. A shovel, if you're using for prying, guess what? It's also a lever too. So there's just some ideas there. Now I did want to also talk about what is the difference between a doorknob and a faucet. Okay, now these faucets here are old-fashioned. When you turn them on, they start screwing up. Okay, these are here actually screws. It's probably more evident if you saw one of these, because you know when you start turning these ones that they screw in and they screw out. They're a very proficient way. They have a screw bottom inside the faucet. It clogs it up to shuts it off. Okay. Okay, so then one more thing. I think that when you're looking at those different options that students were talking about in that survey, I think that what they're talking about is organization. Okay, so organization can help us with a lot of this. So let's go and organize ourselves here quickly. Okay, so what I want you to do right now is I want you to go ahead and write down the different formulas for these, and then I will just discuss them. I'm not going to type them out. I already did that in notes once. So go ahead and pause this, and then let's go ahead and talk about the different formulas. Okay, so when you look at a lever, the MA or AMA, the IMA of a lever is pretty nice. It's just the length of the effort over the length of the resistance. Notice that they're lengths. Okay. Now the incline plane, that right there is pretty nice too. That is the length of the ramp. Okay. And when we're talking about that, the length of the ramp, let's see, where have I got that picture? The length of the ramp, here's the length, is over the height of the ramp. Okay. And when let's also, now again, those are two lengths. So when you're looking at this formula here, this one was lengths. The inclined plane, it doesn't matter if you talk about it as a wedge, a ramp, or a screw. I mean, you're talking about measuring really minute ones, so those ones won't be very typical of it in a test, but a ramp definitely would be. But so far, these are all just lengths. The wheel and axle. The MA of a wheel and axle is the radius of the wheel over the radius of the axle. You're going to have the same exact ratio if you have a diameter of the wheel over the diameter of the axle. So you can set it up either way. Just know that you must keep them the same exact measurement, diameter, diameter, or radius, radius. So these three right here are all measured with lengths. So when you're given a problem and you see it says centimeters, you see it says meters, then you know that it's one of these three formulas right here. Okay, a pulley, what do you have to do? You have to measure some strings on string systems on your pulleys. We're going to talk about that here too. Okay, so write down these formulas. Okay, so you had those. And then let's talk about how we measure them with a pulley and how we measure them with a lever. So let's quickly review. Okay, if you're going to be doing work, okay, you have to move something. Okay, you have to push it or pull it, and it has to go a distance. And it has to go in the same direction that you're pushing it or pulling it. If it goes in the opposite direction, then it's negative work. If I'm going to pull on my horse and my horse is going to pull on me and she's going to win, then I'm getting negative work done. Okay, but if it's going off at an angle, then we're only getting just a portion of our work. But if it's going off at 90 degrees, definitely no work is being done. Okay, so this right here, when she's lifting up this barbell, okay, when she's lifting up the barbell while it's going up, it is definitely work. But we've talked about this several times, and it was in one worksheet. While they're holding it up there for those few seconds that they do, there is no work being done because during that duration, no movement. Okay, and these ones are here. If you remember right in the notes, we were talking about the direction of your force has to go in the same exact, your motion has to go in the same exact direction as your force. Okay, we also talked about the work formula, power, where we take work divided by time. Make sure that you've got your units written down for this, because when it's the stress of a test, you can screw up. We got joules over seconds, okay, which makes a watt. Okay, and we did work problems, and then we talked about simple machines. Okay, and we talked about those. Okay, I'm trying to get to a lever here. Here we go. So when you're going to go and measure the parts of a lever to get the length of the effort over the length of the resistance, when you're doing that, make sure that when you're measuring it from the fulcrum. So from the fulcrum to the middle of the effort is the length of your effort. Okay? The length of your resistance is your weight. The resistance is your weight. Sometimes effort is called applied force. Resistance is sometimes called the weight of your object. Anyways, from the middle of the weight to the fulcrum is the length of your resistance. Okay? They will be in the same measurements. If they're not, you need to fix them. If one's in centimeters and one's in meters, you need to fix that. Okay? And so here are several different levers, and I think that this is kind of a hard part. So when I look at these levers, I kind of just remember what's in the middle. Okay, if my load's in the middle, I remember it's a wheelbarrow, that's second. If I am applying all my force in the middle of it, I know it's a third class lever. Okay, and I know teeter-totter is a first class lever. So that's how I remember these. And so you can go through this in your notes again. But thinking about this tennis racket, okay, here's the resistance where he's going to hit the ball. His muscle is his force, and it's pivoting right here. So when you talk about that, you're talking about a third class lever. Okay, and so here again, third class lever because of where our force applied or effort is, and here's our resistance. So I think that third class and second class lever is the hardest generally for students, because when it pivots in the middle like this, we know that it's going to be a first class lever. So here's one that's pivoting at the end, and here's where your walnut is or whatever, and so that's in the middle. And then here's your effort force at the end. So that's going to be a second class lever. And I've just always memorized it, and you guys don't have to memorize. You're kind of fortunate for that part. But wheelbarrow's got the load in the middle, the resistance, and that's kind of how I've always remembered what a second class lever is. Okay, so for your levers, I think that's probably easiest to remember by what is in the middle of it. It doesn't matter if it's flipped around. What is in the middle of it, and so that can help you identify them. Use your notes that way. Okay, wheel and axle. Okay, so screwdriver, doorknob, those are all wheel and axles. You've got a larger thing that you're turning to move a smaller axle inside of it. Okay, they used to have bigger wooden grips on screwdrivers, and then some of the snap tools too have got these other shaped ones that are quite large too, which makes a bigger wheel for the axle, and so that makes you have a larger mechanical advantage. And that's really what it's all about. A larger mechanical advantage just helps you have more ability to use less force. Okay, let's inclined plane. You remember that formula. Okay, here's an inclined plane wrapped around a cylinder. Okay, and this one. Now, notice that, okay, I know that you know that the MA is already all written up here, 1, 2, 3, 4, but just look at this. Okay, some people say, oh, there's one because it's got one pulley, but that's not true. It's talking about how much of the rope is separated from the mass. So right here it's separated in half from the mass. So it'll be twice as easy. Here it is separated 3 times from this mass assembly, weight assembly down here. The rope is separated 3 times. So it's going to have a mechanical advantage because each one of these ropes is going to take 1/3 of the load. So it's going to have a mechanical advantage of 3. Okay, here we go again. This weight assembly right here is separated 4 times. And so it is crazy how easy it is to pull on this, and you're thinking like, wow, but it takes a lot of string, so you're pulling a lot to get that right. I think that if you want to review some of those, that we did have some examples of when they weren't the number of wheels on that last page, because this one you definitely know that it's got 1, 2, 3, 4 times that this mass has been separated. So it's going to have an MA of 4 because this is taking 1/4 of the weight off of each string, part of the string. So that's definitely a way. I'm kind of running out of time here. Let me go look at my list again. So I'm trying to anticipate your questions. And so we've talked about all of these. Not this one too much. This is the only one that's measured in forces. Okay, and so it's the force of resistance over the force of the effort. And that's the only one, and that's our actual mechanical advantage. And so if they give you a problem that's only measured in forces, all the others are measured in lengths or else pieces of string from a pulley. So then you know that you can follow this formula. So look at your units. Remember, I told you that if you're not reading it clearly with stress, definitely your units can really help you out. We've talked about the IMA of a lever, inclined plane, all of those. How to identify the different levers. I think that what would help everybody the most is to take a few minutes, write down all the formulas, remind yourself that MA does not have a unit, and remind yourself the work and power formulas and their units and how they just write down all those formulas on a sheet. Give yourself a moment because that helps you process it again. And so then that'd be a better reference sheet for you in the long run anyways. But I got to go because I'm running out of time. Don't forget, I Zoom today, Thursday at 1 o'clock. See me if you want to see me. Come on. I'm there. Bye-bye.